Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing 2.5, 2.7 quiz review. And it can be found on page 90. Okay, so this here is the quiz review from the book, 2.5, 2.7 quiz. Questions 1 through 7, it shows you where to get the information or the lesson that will help you with this problem. So 2.5, 2.5, 2.6, 2.7. We are talking about similar figures, in which case proportions are used. What I want to do with you, I want to set up problems 8, 9, and 10. Okay, so we need to know how to apply what we've done to real world, real life. So what I'm going to do with you is set up problems 8, 9, and 10. So let's take a look at 8, screens. The TV screen is similar to the computer screen. What is the area of the TV screen? Okay. So we have 2 rectangles. This is the computer screen. It has a length of 12 inches and an area of 108 inches squared. This is the TV screen. It has a length of 20 inches, and we want to know what the area is. Okay, and the problem is telling us they are similar. They are similar. So we're going to set up our proportion. Our proportion is going to be the computer over the TV. So the length of the computer is 12 inches, while the length of the TV is 20 inches. Okay, and that should be equal to the area of the computer is 108 inches squared, and we want the area of the TV, X inches squared. So the first thing I'm going to do is reduce this fraction so that I'm working with smaller numbers. It makes it easier. So 4 goes into 12 3 times, and 4 goes into 20 5 times. So my numbers are a little bit smaller, makes it a little bit easier to work with. But now we kind of have a problem because we're dealing with inches and inches squared. Inches is linear, it's a line. Inches squared is area, and it's square boxes. So we can't say a line is equal to a square, right? They're 2 different things. So we need to do something to make sure we're dealing with the same thing on both sides. So what we can do, we can square this. So now 3 squared is 9 inches squared. 5 squared is 25 inches squared. Now we have inches squared and inches squared. We're comparing apples to apples now. Now this works. So we're going to set up, we want to make sure that they are proportional. We're going to use proportions to determine X. So we're going to cross multiply. 9X is equal to 25 times 108. And then this becomes an algebra problem that you already know how to do. So I'm not going to solve this for you, but I did want to set this up with you. Okay? So that's number 8. Now let's take a look at number 9, geometry. The vertices of a rectangle are A, B, C, and D. Dilate the rectangle with respect to the origin using a scale factor of 1/2. Okay, we know how to do this. So this is number 9. We have our vertices. A is 2, 4. B is 5, 4. C is 5, -1. And D is 2, -1. Our first transformation is a dilation with a scale factor of 1/2. So we're going to multiply 1/2 x, 1/2 y. And that's going to give us a new set of ordered pairs, A prime, B prime, C prime, D prime. Okay, so we're going to end up with a new set of ordered pairs for our image. Now, then the problem is telling us, then translate at 4 units left and 3 units down. What are the coordinates of the image? So they want us to do a second transformation. We're going to translate. They want us to translate 4 units to the left. Now, left and right is x. To the left means -4. Up and down is y. They want us to go down, which is -3. So we're going to take this set of coordinates and we're going to go x -4, y -3, and that's going to give us another set of coordinates where that second image is. Okay? So I'm not going to do the work for you, but I did want to help set this up with you. So the vertices of the rectangle are A, B, C, and D. Dilate the rectangle with respect to the origin using a scale factor of 1/2. Then translate it 4 units to the left and 3 units down. What are the coordinates of the image? So that's exactly what we've set up here. Here's our original coordinates. Our first transformation is a dilation with a scale factor of 1/2. That's going to give us this set of coordinates. Then we're going to translate 4 units to the left and 3 units down, which will then give us our final set of coordinates. Okay? And I want to set up number 10 with you. Number 10. Okay, tennis court. The tennis courts for singles and doubles matches are different sizes. Are the courts similar? Explain. Okay, so we have one tennis court that looks like this. This is our singles. It's 27 feet by 78 feet. And then we have our doubles, which is 36 feet by 78 feet. And we want to know, are they similar? Are they proportional? So we're going to set up our proportion. Singles over doubles. Our height is 27 over 36, and it should be equal to our length over our length. So now we're going to cross multiply. 27 times 78 should be equal to 36 by 78. If they are equal, that is proportional, which means they are similar. If they are not equal, then they are not proportional and they are not similar. So this is what we are doing today. You are going to solve problems 1 through 10 on a piece of paper. Take a picture of your work, and that's what you are submitting. So for questions 1 through 7, it tells you what section to look at for help if you need it. And together, we've just set up questions 8 through 10.